All right, so verifying, technically this is 5.2. Just covering a little bit because in 5.3 and 5.5 there are some identities, like sometimes we want to verify it and like use an identity, and the only way is to like say, oh, okay, can I change the left side in order for it to equal right? This is not really any different than the previous page. It's just instead of like going through and simplifying and you don't know when to stop, I tell you when to stop. I say, hey, guess what? Let's work on the left side and let's try to simplify it, and it should equal secant to the fourth power of x at the end. So I tell you what it should be. So I think verifying is actually easier than simplifying because it tells you where you should be. It gives you an idea, and then you can kind of see like, okay, if I'm supposed to end with secant at the end, maybe if I see like 1 over cosine, I could just change it into a secant, and then I see where I'm on my way. Okay, so how do we actually verify? It's very similar to simplifying. You start with the more complicated side. So clearly in A, this is more complicated because it, we have a fraction, we have 2 terms on top, 2 on bottom, and then the right side is just literally 1 term. So start on the harder, more complex side, and we want to turn the complex side into the simple side, aka simplify the left side until it equals the right. That's our stop sign. So we want to be using the reciprocal, quotient, Pythagorean, and other basic identities, trig identities. So this is all the stuff we learned in the first section. And then if we have to use basic algebra like combining fractions, taking fractions and adding and subtracting them, multiplying expressions, factoring them, converting a denominator by using the conjugate, right? So if you have like 1 minus x on bottom, the conjugate would be 1 plus x. Literally, it's the other half of a difference of squares. Do you remember what a difference of squares is? Yeah, it sounds familiar-ish, difference of squares. That's where this is coming from. So if I would have something like x squared minus 25, the factors would be x minus 5 and x plus 5. So if I had something like 1 over x plus 5 and I multiply by the conjugate, literally you're multiplying by the other half of the difference of squares. That way on the bottom I could end up with just a difference of squares. Okay, we're going to go over multiplying by conjugate at least like 30 more times, so don't worry. Work each side separately to reach a common intermediate expression. If it's super, I'm not going to ask you one that hard, so don't worry about that one. Intermediate, no. We always can get the left side equal to the right side. If no other strategy presents itself, try converting the entire expression into only sines and cosines. I don't know. We're not really going to go that deep into 2. I just want to show you verifying versus simplifying. So example 1, tan squared x plus 1 over 1 minus sine squared x is equal to secant to the fourth of x. So what's the first thing that pops out at you? Think in your head. Take about 5 seconds. Think, what would you do first? What's the first thing you would do? Take 5 seconds in your head. Now turn to the partner next to you and let's share. Turn to the partner next to you. What's the first thing you do? Do you have any ideas? Okay. Let's see. Chelsea, what's the idea?
We thought Pythagorean.
Okay, for what?
What do you mean?
What makes you say that? Why?
Because tan and sine are both squared, and secant is to the power of 4. And then maybe?
Yeah, so the Pythagorean identity jumps out at you. You're like, okay, I see a trig function that's squared being added to 1. And on the bottom, I see 1 subtracting a trig function that's squared. So whenever you see a 1 and a trig function that's squared, like being added or subtracted together, that screams Pythagorean identity. We just have to figure out, like, what does it actually equal? So I see tangent. I know the one with tangent. Looking on our little identity sheet. We have our identity sheet with us, in front of us? Yeah, I just recommend, have it next to you. So in class, you can refer to it. When you do your homework, you can refer to it, because I'm printing a copy. It's going to be stapled to the quiz, and you'll have the blank copy. Literally, exactly as I gave it to you is how I will give it to you on your test and quiz. Awesome. You can, write notes all over this one, whatever, because I'm going to give you a blank copy on the quiz day and blank copy on the test day. All right, so if I look at the Pythagorean identity with tangent, it's tan squared x plus 1 equals secant squared x. Oh, so this is exactly what we have. So I could plug in secant squared x for this. And then if I look at the one with sine. So I look at the one with sine, and it says sine squared x plus cosine squared x is 1. That doesn't really match. That doesn't match. So if I subtract sine on both sides, let's see if I get. I get 1 minus sine squared x. This is exactly what we have, so I could plug in cosine for the bottom. So you may have to like manipulate, move things around a little bit on your identity in order for it to match what you have. But I mean, you can still do it. Okay, so on top, I have secant squared x, and on bottom, I have cosine squared x. And I should probably be specific. Since we're verifying, I draw a line, and at the end, my goal is to make the left side equal the right side, and the right side is secant of x to the 4th power. So somehow we're going to work on the left side and be moving it until it is equal to that. Okay, so right now, I have secant squared x on top. So I'm halfway there, right? I'm supposed to have secant to the 4th, and I have secant to the 2nd. Then I have this like cosine squared x on bottom. So maybe I should rewrite this a little differently. So if I say, okay, secant squared x times 1 over cosine squared x, how could I rewrite this portion? Yeah, this is literally secant squared x. So I have secant squared x times secant squared x. So question for you, if I take x squared and multiply by x squared, what happens to the exponents? You add them together, right? Versus if I had, well, this isn't a great example. Okay, what if I have x to the 3rd to the 2nd power? Like when you have a power to a power, you multiply. Let me change this number just so you can like see the difference. When you are multiplying the bases, you add the exponents. When you have an exponent to an exponent, you multiply exponents. Just a little review of Algebra 1. Okay, cool. So up over here on the left side, I'm going to be adding the exponents. So I turn out to have secant of 2 plus 2 is 4, secant of x to the 4th power. Cool. I got it. We did it. We verified. We knew when to stop. That's a stop sign. This was our stop sign. Ah, I missed it. I should have made it red. Whatever. It's an octagon. It's not good. I don't teach art. All right. Whatever. Cool. All right. Let's do B. So this one's a little complicated, but the simpler side is the left. So our goal is to make the right side equal the left. Can I scroll up? I don't want to rush you if you're writing. Yeah, we're good? Okay. I just, I'm very cognizant of the fact that sometimes I talk very fast when I drink coffee. So I am cognizant of that fact. Okay. I just had a student the other day who's like, I just can't keep up when you write. And I'm like, okay, slow it down. All right, so we know what our goal is. We know our stop sign. That's what we should get to. And otherwise, we're just, simplifying the right side until we reach its -2 cotangent x. Okay, so normally we look at it, we say, can we get it all in one trig valid function? No, it's in sine and cosine. It's already in sine and cosine, so we're good. But how can I simplify it? Right now I have 2 fractions. Exactly. Let's have a common denominator. All right, so I don't know the common denominator between these, so I'm just going to multiply them together. So on the left side, I will take 1 minus cosine x over 1 minus cosine x. And on the right side, I'll take 1 plus cosine x over 1 plus cosine x. So the first thing I'm going to do is I'm just literally going to rewrite it. So sine x times 1 minus cosine x. Just a moment. Minus sine x times 1 plus cosine x. All right. And the bottom is just going to be 1 minus cosine x times 1 plus cosine x. Okay, so I just rewrote it. So that way, instead of having 2 fractions subtracting, I have a common denominator, combine them into one single fraction. All right, Daniel?
Is it fine if we use the identity to switch the order to 1 minus cosine x, just sine squared?
It's not, because this is not squared. 1 minus cosine x is not 1 minus cosine squared x. So you got to be careful. It's not squared. Yeah. It's good. It's tricky. So just to make sure we're all clear, right here, he's like, oh, this is almost like 1 minus cosine squared x, but it's not squared. So can't use Pythagorean yet. But guess what we're about to use on the bottom here? What is this? This is a difference of squares on the bottom.
Oh, yeah.
So when I multiply the bottom together, I'll have 1 minus cosine squared x. And then this is where I could, and then the next line is where I'll put like sine squared x. Okay, so he recognized that this is difference of squares. Multiply it out. Guess what? This is what sine squared x plus cosine squared x equals 1. So sine squared x is 1 minus cosine squared x. Just moving it to the other side, and then since we have this, I could put in sine right there. All right, so we, did like 2 steps ahead with the bottom, but we got to figure out this top first. So I'm going to distribute, and I'll see if anything, cancels out. So I have a minus sine x and a sine x that goes away. And the top, I'll be left with negative 2 sine x cosine x. Okay, so if you're done writing, think for about like a couple seconds. What would be the next step? What do you think the next logical step would be? And as soon as you come up with an answer, like 3 more seconds, turn to the partner next to you, and let's see if you guys agree.
Divide by sine.
Okay, that's better. I was running out of room, so I cheated and I moved it out. Okay. All right, so we've come to a conclusion. Jolie says, hey, guess what? Divide by sine. So I'm just gonna show you why she said that. I'm just gonna take this over here. Negative 2 times sine x times cosine x. Remember the bottom is sine squared x. That's just sine times sine. So guess what? That guy cancels out. 1 sine on top, one of them on bottom, and one of the top ones cancel out. So I'm left with negative 2 cosine x over sine x. Not quite done yet. What? Wait, is it clear?
Yeah.
I don't know why you're laughing. Ariella.
Cosine over sine is tangent, so wait, isn't it?
Cotangent.
Cotangent, yeah.
So it's just going to be negative 2 cotangent of x. Wait, hey, that's what we're supposed to get.
Oh, yeah.
Okay. Yeah. Oh.
Yeah.
Ooh. Yeah. Okay. It's just nice when things work out. It is. Like, imagine, spending 20 minutes on a problem, and you know what the answer should be, and you just never get it. Yeah. That was me, freshman year of physics, just crying all the time. I'm not even joking.
Physics as a freshman?
In college. I mean, everyone has to take, there's like 8 classes every undergrad has to take. Let's see, kinematic physics, electromagnetism physics, Calc 1, which is single variable calculus, Calculus 2, which is multivariable. You have to take differential equations, and there's 3 different humanities, arts, social science classes you have to take. Every single undergrad that goes through MIT has to take it, regardless if you're majoring in linguistics or chemical engineering.
Wow. Wait, you went to MIT?
Oh, yeah.
Oh.
Yeah, I did. I don't know. I don't tell people that. Hey, you went to MIT. Can you fix my computer? No. Like, what? That's dumb. Goodbye. Yeah, I know. I went there and I'm here. Okay. It's fine. We're good. Okay. Yeah, so, right. Which is why it's funny when people are like, I'm like, really? Really? Nah, I only, let me pause. Like, I don't know. It comes out, it comes out rarely. But like, when someone comes up to me and they're just so rude and they got that little holier than thou, like, I'm so smart, please tell me. Please, okay. I just hate these people who want to have like a contest. I watch these little cocky people. Oh, I'm so smart. Okay, please tell me how. Okay. I don't know. Yeah. I don't know. I quit telling people that. Whatever. It's my personal life. Yeah. But yeah, so I know math. There you go. I have done the math. Okay.
Wait, were you a physics major?
Okay, fine.